Alright, so problem number 12. The zip line problem. Okay, we got this straight from your book, right? And they said that they had a ratio of 3 to 5, right? But they want us to do a linear equation, right? So, because I see the word linear, I'm going to think line, right? And I'm going to think XY coordinate. Okay? This is your Y, this is your X. Alright? So I think XY coordinate. This comes from Algebra 1. So this is what I have to reteach you guys. Right? We talked about it in chapter 1 and in chapter 3. Okay? And then it says that it's attached, right? It's attached somewhere, we don't know where. And it falls, right? And it attaches here. And then, so you got this guy, he's coming down the zip line, right? Woohoo! Right? Having fun. Okay. And it says that it's 10 feet off the ground, right? So that we know that this is 10. Okay? So if we kind of take a look at this, we know that's 10 right there. Does that make sense? Then we have this right triangle. And then the other thing it says is that the fall is 3, right? And the run, so the fall is 3, but the run, wait a minute, the run, let's do that in blue. The run is 5. Okay? So we know that it's falling 3 and running 5. That's a 3 to 5 ratio. Right? So in other words, 3 to 5 we need to know is like this. And maybe I'll write it so you can see the color code. But a 3 to 5 ratio is written as a fraction 3/5. And we should also know rise and run, well this is negative, right? The thing's going down. But it's running 5. So now I know the slope is negative 3/5. Okay? So I know right now, since y equals mx plus b, right? I know that the slope is negative 3/5 x plus b. I don't know what b is yet. But I do have an equation almost. Almost. Okay? Almost. I just don't know what b is. And to find b, I have to find how high. Like, where is it attached? Does that make sense? But I need something. I need something. What do I need? Oops. Plugging these into the wrong thing. Did I drop a pin? Oh, there it is. Okay. It says the zip line is 100 feet from the zip line to the end, right? So this is 100 feet. We know that this is 100 feet. Okay? From the base to the base. Okay? And so now we've got it. Believe it or not, we've got it. Now next chapter we're going to talk about ratios and similar triangles and how these ratios are the same. But I'm already teaching you that right now. And that is, if there's something that I can multiply 5 by to get to 20, to get to 100, right? So what times 5 is 100? 20, right? I just said it, my bad. I do that a lot, right? So what we're doing is we're saying, hey, 5 times 20 is 100, right? Sorry about that. 5 times 20 is 100. So that's how I get from this line to this line. So I'm going to do the same thing to go from this line to this line. Does that make sense? So I'm going to do 3 times 20. How much is that? What's 3 times 20? 60. Okay? Alright? That means this piece right here is 60. So if that piece is 60, how high are we attaching that zip line? Not 40. 60 and 10, right? 70. So B is equal to 60 plus 10, right? The height of the zip line and the height the zip line is off the ground, right? Zip height and the ground. Oops. Ground height, right? So we're adding those two pieces. So now we know that this is 70. So now we know that the equation is y is equal to negative 3/5 x plus 70. Right? That's nice. So we have part. How high is it off the ground? Do we know? 70. So we just figured out two of the problems. So it's 70 feet off the ground. Does that make sense? Alright. Now, they want to know what's the diagonal distance. In other words, how do we figure out this piece right here? And that one we go back to the whole a squared plus b squared equals c squared, right? The Pythagorean theorem, right? So I heard I'm lost, like, right? Like, how do we come up with the a squared plus b squared equals c squared, right? All right. So remember, this is every right triangle, A, B, and C. Okay? And in every right triangle, we have the a squared plus b squared equals c squared rule for every right triangle. So that's all we're using is that rule. And C is always across from the right angle. Okay? Stay focused. Come on. All right. So which one do you want to do? And this is the fun part to me, right? Is because I'm like, I could do the 60 and the 100, or I could do the 3 and the 5. Right? Why not do the 3 and the 5? We'll figure out this length. Now, why am I going to figure out this little guy? You can multiply it. That's right. Because then we could just multiply by 20. Whatever that answer is, we'll just multiply it by that same thing we did to the other two sides, right? Yeah, exactly. That's the key to this equation, to making the math easier. Does that make sense? So we're going to take this triangle, this 3, 5 triangle, we're going to figure out what C is, right? Guys, Skylar, come on. You need to stay focused. People can't focus if you're talking to them. All right. So what's A? What's A? Which one's A? 3. And it doesn't really matter, 3 or 5, because they're both legs. The one thing that matters is that C is always the hypotenuse. Okay? A and B could be B. It doesn't matter, right? Because 3 plus 5, 5 plus 3 doesn't matter, right? Same thing. Okay? So 3 squared plus 5 squared equals C squared.